The trapezoid rule, this is just another approximation method. All right, if you need to evaluate a definite integral involving a function whose antiderivative can't be found, the fundamental of FTC number 2 cannot be applied. Okay, then you must refer to an approximation method. Okay, so say we don't know this, how to take this antiderivative, so we're going to do an approximation method. We have LRAM, RRAM, MRAM, and now it really should be trapezoid approximation method, but just to make it all go instead of, because that R stands for rectangular, right? So we're going to put a TR in there for trapezoid, TR, right? The TR there. So we can say LRAM, RRAM, MRAM, and TRAM. Okay, so another way to approximate the definite integral is to use trapezoids. Regular partitions and area of a trapezoid, just as easy, 2 bases times the height. All right, so let's do this from here to here. And we'll just partition. All right, and so you've still got your regular subinterval, so you've still got B minus A over, is that an N? Yeah. So that's my delta X. Same thing, but we're going to actually call that the height. So this is going to be a base, and this is going to be a base of the trapezoid, and this will be the height, right? Okay, and this will be, so this will have base 1, base 2, you know, this one will have 2 bases, 2 bases, 2 bases, 2 bases. And I'll call these a height because it's the height of the trapezoid, but really these are heights in terms of algebra, and this would be, you know, more of a base, but I'm going to call this height. Okay, so each one of these trapezoid is going to have the same height. So in front I can throw out the height. Remember, that's just your delta X, which is just your B minus A over N. Okay, so the first trapezoid is going to have an area. Let's see. Let's just do the first trapezoid right here. Let's do trapezoid 1. It's going to have 1/2 height, base 1 plus base 2. All right. And what are my bases going to be? Well, this will be f of x sub 0, and this will be f of x sub 1. Okay, so trapezoid 1 is going to be 1/2 height, f of x1 plus f of x2. Okay, so that leads me to believe that not only, you know, all those trapezoids are going to have this built in, this 1/2 and this height. So now I'm going to go ahead and factor that 1/2 out also. So out in front I'm going to put h over 2. And it might help also just to even do, let's factor out the 1/2 and the height, just so you can see it. Okay, so the first trapezoid is going to have f of x0 plus f of x1. Okay? I guess we haven't, let's factor it out right here, because these don't have it all built in here, so we'll just do that. We'll factor it out on the next line, dot, dot, dot. Okay, so this next one is going to have a base of, this is used again, and now we bring in f of x2. Okay, so that's interesting. So I'm using that not this one twice. This is only one base of one trapezoid, but this is one base of the first trapezoid and a base of the second trapezoid. This one is used twice. Okay, and then this one uses that again, that x of 2, that f of x of 2 again. So it's getting used twice. You can probably see where we're going with this. So you go all the way down to the end here. You've got this f of x n minus 1 plus f of x n. So what's going to happen there then is we're going to factor out the 1/2 h from each one of those since it's regular, and then 1/2 is everywhere. I'm going to use f of x sub 0 once. Everyone in, not except the first and last trapezoids, all of the internal, bases, if you will, are going to get used twice. Twice. Dot, dot, dot. Okay, and that's what we look like. Okay, so factored out the 1/2 h. First base, the second base gets used twice, twice, all the way until the last one that just gets used once. So all of these are double dipping in here, if you will. Okay, so when you have a t-table, it's really easy to look at. Okay, so continuous. Okay, and so the trapezoid rule is going to be, let's do this, h over 2. So it has to be regular. All right, this h is b minus a over n, and they have this pattern. Okay, so got that out. So we got f of this initial point to the next to the last one. All right. So the coefficients in the trapezoid rule have this pattern. Dot, dot, dot. Right, however many partitions you have. Okay, so let's use the trapezoid rule. So let's make our t-table and just kind of compare that to an LRAM and a RRAM. Okay, so if I plug 0 in here, I'm going to get 0. 1, I'm going to get 2. 2, I'm going to get 10. 3, I'm going to get 30. And 4, I'm going to get 68. Okay? And so, if we were making these trapezoids, they would look like this. You would connect like that. And you can see that's a really nice, a much nicer tight fit to the curve. So 1, 2, 3, 4. And as you just go from endpoint to endpoint, it really, really is going to be a good, if not great, approximation. Okay, so we have got the function from 0 to 4. Delta x is going to be 4 over, 4 over, so we're doing the 4 over 4 here. 0 to 4 over 4. So I guess I could have kept 4 over n, but we know n is 4 of these. Delta x is 1. So I'm going to factor 1 out. That's your height. Each one of these have a height of 1. And then times it by 1/2. Okay, so on your t-table, an LRAM uses these heights. An RRAM uses these heights. But a TRAM is going to use all of them. Okay, it's going to use this one once, this one twice, this one twice, this one twice, and this one once. So make sure you don't leave anybody out on the trapezoid. All right, so here we go. So that's 1/2 height, which is this base, and 0 plus 2 times 2 plus 2 times 10 plus 2 times 30 plus 68. All right, and so that's just 4 plus 20 plus 60 plus 68. Okay, so that's just 2 plus 10 plus 30 plus 34, 76. All right. So the graph is concave up on 0 to 4. And so you can see that these trapezoids are a little bit over. So this is an overestimate. All right. Algebraically, how would I show that it's concave up from 0 to 4? Well, we can just do first derivative. Second derivative helps with concavity. Just 6x. And 6x is positive for all values 0 to 4. Okay, so trapezoid rule, kind of fun. All right, I'm going to flip the page, which says to find the exact value of the integral. So we can do this one. We didn't really need a TRAM here. Here we go. Okay, and so this is what? X to the 4th over 4 plus x squared over 2. 0 to 4, we like zeros. 64 over 4 plus 16 over 2. All right. Oh, not 64, shoot. 56, huh? 4 to the 4th is 256. Okay, which is then 64 plus 8, which is 72. So what do we get on the other page? 76, I think. Yeah, 76. So pretty good. Not too bad there. Okay, so conclusion. If f is concave up, then the approximation from the trapezoid rule is an overestimate. Okay, so let's just draw a big trapezoid here. If we're concave down, then it's an underestimate. Let's just do a big trapezoid here. Okay, and that's just a little visual for you. Okay, next little question. Cindy raises fish in the pond shown. The average depth of the pond is 4 feet. Okay, and estimate the total volume of the pond. Okay, so this depth, we need the surface area. Okay, and then we need the volume. Okay, so a couple of things. So we're just going to be doing this total area here, and then multiplying it by that depth of 4. So this is the 4 right here. Vertical spacing of 10 is important. So these are my trapezoids. So 10 is my height. These are spaced by 10. Okay. Over 2 for that 1/2 that's in the formula. And then we're just going to grab 0 once, 29 2, 31 twice, 2 times 2, 1, and then 0. Don't really even need those. So 5 times 58 plus 62 plus 42 plus 32 plus 40. Okay, so 58 plus 62 plus 42 plus 32 plus 40. Times all that by 5, it comes out to 1170 square feet. And so we just take that and multiply it by that average depth. Okay, cubic feet. So estimation for Cindy there. Okay, if Cindy raises 1 fish per 3 gallon of water, 1 cubic foot is 7.41 gallons. How many fish can be raised in said pool? Little dimensional analysis here. 1 fish per 3 gallons. Okay, and let's let's start our numbering here. Let's use this here. This is 7.481 gallons per cubic feet. All right. Okay, so we're going to multiply that by our previous answer. I mean, we're looking to get fish per cubic foot. So we got our gallons out. Oh no, how many fish total? Sorry. We're looking for how many fish. How many fish, not per. Okay. And then we've got our 4680 feet cubed. There we go. So we're just going to multiply all that. Okay, so it looks like to be 11,670.36 fish. Okay, moving right along here. Checking my time. The kiddie pool at Summertime Splash Place is 18 feet by 25 feet. The table shows the depth. H of x over the water at 5-foot intervals. Estimate the volume of the water in the pool using the trapezoidal rule with n equal to 5. So this volume then is going to be the surface area, which is going to be here. Okay. Sorry, you couldn't see that. The surface area is going to be here. All right. And these depths are partitioned from 0 like that. So that means this is 25 by 18. So this is going to be 18 by whatever we find right here. We're going to go trapezoidal rule from 0 to 25 and then times it by that 18. So let's accumulate all this stuff under here with these trapezoids. All right. So there's just the 18 that's going to pop out, and then we're just going to do this. That's the 18 I have down here. 0 to 25, h of x dx by the trapezoid rule. All right. So these heights of the trapezoid are 5. That 1/2 from the formula, and we're going to use 1, 1.5, 2, purposely leaving space here. Okay, so those are all the heights in the table. So that's just times 2. That's just times 2. That's just times 2. That's just times 2. And this last one times, so times 2, times 2, times 2, times 2. All the internal y values. All right. So this comes out to be 5 halves of 1 plus 3 plus 4 plus 5 plus 5 plus 2. So 10, 16, 19, 20. So it should be 50. So we're going to multiply that other dimension of 18 by all this underneath that has the 50, and it's going to be 900 cubic feet. No dimensional analysis needed there. So what happens if you don't have regular subintervals? No big deal, just add up your trapezoids. Okay, so at 1, we're at 10. Let's do this quickly, so I have to leave. Okay, 1, 2, 3, 4, 5, 6, 7. 1, we're at 10. 4, we're at 30. 6, we're at 40. And 7, we're at 20. Okay, so this first trapezoid looks like this. Alright, this next trapezoid looks like this. The next trapezoid looks like this. So We have 3 trapezoids here, and we just got to do all 3. This total area then is 1/2. First base is 1, 2, 3, and the 2 heights are 10 plus 30. I guess you could factor out the 1/2, but let's just do each one. This next is 2. That's a height there of 2, or interval length of 2 here. Looks like a base, but we're thinking about its height. And then this is what 30 and 40. Plus the last one has a 1, and then those two are 40 and 20. Trapezoid rule is pretty easy and intuitive here. So this is 40 times 3, that's 120. Half of that is 60. That's 70 times 2, that's 140. Half of that's 70. And then last but not least, this is 60. Half of that's 30. So approximation of 160 units squared. All right, next video will be our exam prep. Okay, I'm going to take off. We'll see you guys in class tomorrow. All right, bye.